Hello and welcome to the HGC. This is Daniel and today's video is repair file M, repair number 4840. Today's repair is going to be of the 5-volt power rail. And before we get started, I want to say this straight up. If you're considering repairing your own system, if you're not capable of listening to every single word I say and watching the entire video start to end, you should not, repeat, should not even attempt this repair. You will need microscope cameras, you will need serious soldering skills, and with that said, let's go on. Alright, so let me back up here. Before anybody asks what size wire to use, you see this little tiny thread here. Anything this size or larger will be perfectly fine. I would recommend a little bit larger. You'll see what size I'm using. Now keep in mind this is magnified several, probably 80 to 100 times. This is all very tiny stuff. This little wire here is like the width of a tiny baby's hair. Alright, so let's show you how we're going to fix this. Alright, so here this pad's ripped up. You don't want to cut this off because this capacitor here will only have one leg on it. So the best solution is to lay this down best possible, glue it in place. When you put your port on, run a wire, one wire from the leg all the way down here. You're going to solder it here and here and here, and then run that wire straight back because this is torn completely off apart here. You're going to run that wire and solder it here and here. You'll see that a little bit later. You can see this is a grounding point. So all of this is what it used to be connected to. We're going to basically expose some copper here, and as you can see there's a little tiny wire going to the bottom of this cap and then down. So we only need to run a wire from this leg to the bottom of the cap, and then this one here is the pane. So let's go a little bit further over. Alright, so we're going to need to remove this, and then I'll show you where that pad goes. So this pad, if you follow the line, it goes all the way up and over to here. So we're going to do some prep work to fix this and get this all laid down. Okay, so prep work. Under the microscope camera, you're going to take a X-Acto knife and very, very carefully take and scrape off the green, exposing the copper. You do not want to expose any copper here or anywhere along here. So be very careful, work slowly. Okay, and then put a little tiny bit of flux right there. Take your soldering iron, prep the spot you're going to solder to. Okay, we're going to move on. This pad here, we're going to expose the copper, taking the X-Acto knife, and that is the point of an X-Acto knife, so you can see how small this work is. Alright, and then we're going to put a little bit of flux. It don't need to be a lot. This is way more than was needed. And we're going to add some solder to it. Now, if you actually need to see a soldering iron touching this to do the work, you should not attempt this. Just saying. Alright, if you don't know how to solder or never have soldered, you don't want to try. And quite frankly, the cost of a proper soldering iron will most likely wind up costing you close to what it would have been for somebody else who's more qualified to do it for you. So best not to. Alright, so now that we got them two spots prepped, we're going to need to remove this little overhang here where it was ripped off the board, like so. Nice and clean, no contact here. Alright, so now we're going to let's see, I think we're going to work on this part here. Here we go. Alright, so this wire was soldered here, up to here, and back down to here. Now, I'm going to get a few comments. Oh my god, that's terrible solder work. Well, you got to remember that this is super tiny and magnified multiple times. It's always going to look terrible at this close of a magnification. But when you solder, you need to make certain that you pre-tin the copper wire, and you need to make certain that the wire is actually making contact with the leg of the port, and then the solder over it. You don't want to put a blob of solder on the leg and then just lightly tack the wire to that glob of solder. You'll wind up with a cold solder joint shortly thereafter, and it will quit working. If the copper wire is in actual contact with the leg and then the solder is holding it down, you'll never get a cold contact. So we welded that or soldered that down here to the first pad that was here. There was a second pad here, and then to the top side of that capacitor there, and then we ran the port down, tacked it to this little spot here, which was just the other side of the tear, and then tacked it here and here. I could have just tacked it to the bottom of this, but I wanted more support because this whole section right here was pretty much ripped off of the board, and you wanted contact with it. Alright, so now that we got that out of the way, let's go to the next leg. Oh, there's the wire. I forgot. That's how the wires ran. Okay, so let's go to the next leg. Alright, so now we're going to do the pad that needs to go from this leg to the bottom of this cap. Place the wire on the leg, solder it to the leg, make certain that the copper is actually making contact with the leg and the solder only is locking it in place. Okay, once that's done, you're going to bend that wire around and solder it to the bottom of that capacitor. Now you're going to want to get rid of the excess wire, so you'll do that with an X-Acto knife very, very carefully so that you do not cut into any of the green portion of the motherboard. Just like so. Alright, now again, this is a little bit more solder than is needed on there, but the copper wire is making actual contact with the bottom side of that capacitor, so it will not go cold. Alright, and now we're going to work on this one, I believe it was. Yep. So we're going to solder the leg, solder the wire to the leg, and then we're going to solder the remainder of the wire to the pad we exposed and prepped earlier. And you'll notice there's looks like flux here. That's not flux, that's actually a hard plastic, and I'll explain that later. Alright, so like I said, this is not flux, this is hard plastic holding this port down. Same over here. So we solder here, get good contact, cut that wire off. Be very careful not to cut into the green portion of the board. The copper is making contact with the leg, the copper is making contact with the board. Okay, then you're going to clean up all of that flux that you used, and definitely use flux every single time. Alright, so we got it all cleaned up. That's what it's going to look like. Now remember what I said, this is not flux, this is hard plastic. Okay, I'll show you how I did that in just a moment because we're not finished doing it. So now we're going to go run the wire to the back side where we prepped the via here. So we soldered the wires directly to the via making certain that the wire is making contact with the copper of the via, and then soldered it in place. And then at that point we're going to bend and wrap this around like so. We want to make certain that it is not going to make contact with this. And here we are on the back side. Okay. Make certain the copper of the wire is making contact with the leg and the solder is holding the contacts together. Alright, so now that we've done that, clean up the flux, and I know there's a little bit of there, that's because it's a very tiny place to work with, and soldering iron sometimes touches that. And this is a little bit of flux here that's going to get cleaned up too. Alright, so now add in some more of that liquid plastic that I was telling you about. So I poured liquid plastic all the way from there, all the way from the back side, all the way around to here. That completely encapsulates this wire, encapsulates the copper so that it cannot corrode or become cold or make contact with a piece of metal or anything like that. And then I'm going to cure the liquid plastic, less than 3 seconds, and it is solid as a rock. That's right, that's a UV light. We're going to add some more liquid plastic directly over the legs and lock down the entire front half of this 5-volt port, like so. Bam, solid as a rock. Do the same on the other side, solid as a rock. And now the port is completely in place and locked down very good. Alright, so this is all encapsulated in a hard plastic. There's hard plastic going all the way around the port, completely covering all of these contacts here, so there's no corrosion from the copper that was exposed, and everything is locked down nice and tight. So now this board can be plugged in. This was in fact a successful repair. Everything worked perfect on the repair. Let's see, was there anything else? This is what I was using. It's called Bondic. It's a US product. I will put a link to a eBay as well as an Amazon link so that you can go straight to it and buy it. This Bondic is absolutely the most wonderful product on the market. Crazy Glue ain't got jack on this stuff. I'm telling you straight up. You can use it for repairing the plastics on laptops where the bolts got ripped out of the frame. You can rebuild a busted case, sand it down, paint over it. You can do anything you want to do with this. You simply put a little bit of this on there, press the light, and within 3 seconds it is solid as a rock. If I wanted to, I can build this up under a giant mountain of that stuff and cure it as I go, and I can have a big giant square plastic piece just like this on this power plug for the 12-volt rail. Alright, so this stuff, if you don't have it, even if you don't decide to fix your own game system and have somebody else do it, I would highly recommend buying one of these things just for repairs around the house, because it is so amazing and just a wonder when it comes to repairing anything around the house, especially anything plastic. Alright, stay safe, happy gaming, guys. And the reason for this video is primarily to show my customer what I actually did to repair his port. Bye, guys.